This video is about using for loops for repetition. Let's imagine that we want to produce the following output. We're printing the first 6 integers along with their squared values. So obviously this code is fairly repetitive. We've already seen ways to represent repetition and redundancy in a program by writing static methods. So the first thing that might occur to you is to try to make this code a little bit cleaner by writing a static method that would print one of these lines of output and then calling that method 6 times or something like that. But actually that solution wouldn't work very well here because the lines aren't exactly the same. The first line prints 1 times 1, the second line prints 2 times 2, so the lines aren't quite the same. They're different numbers each time. The other thing that you notice is that the sequence of numbers that we're processing has a particular property. It sort of goes from 1 to 6. It's a range of numbers. So when we have lines like this that are very similar, that operate over a range of numbers, the intuition is we'd like to say, please print one of these lines for each of the integers from 1 through 6 inclusive. Well, it turns out that Java has a statement that's just built exactly for this sort of thing. It's called a for loop statement. A for loop statement represents a repetition over a range of values, generally a range of numbers. And so the lines of code that I've written at the bottom of the slide now actually have the same overall behavior and output as these 6 lines up here. Basically, the intuition of how to read these lines, there's a lot of funny syntax on this first line here, but the quick intuition is for each number between 1 and 6, I would like to repeat the following statements, and the number that I'm working on at each given moment is called I. So I want to print the number I plus itself squared, and I want to do that for each number I between 1 and 6 inclusive. So that's sort of the quick way of interpreting what that set of statements does. So that's a much more compact representation of the same behavior. Let's look a little more at the syntax of this for loop and how it actually works before we try to program one for ourselves. So here's the general syntax for a for loop. The heading of a for loop starts with the word for and then a set of parentheses, and inside those parentheses there are 3 pieces separated by semicolons. The first piece we'll call the initialization, the second piece I'll call a test, and the third piece I'll call the update. And then inside of the for loop there's a set of braces, and in those braces are some group of statements. So that's sort of the 4th piece of the for loop. When a for loop is executing, it performs each of those pieces in a specific order. I'll relabel those again on this slide. So let's walk through a little bit of how a for loop runs. This slide has the same code from before, except that the loop is only looping up to 3 so that we can walk through it in more detail without having to walk all the way up to 6. I'll label this very last statement number 5 here. There's this println statement after the for loop that prints woo, and the key thing there is that that statement is not inside of the curly braces of the for loop, and so that means that the woo statement is not repeated. It only prints that statement one time after the for loop is finished repeating. So the way that this loop executes is when Java is first executing this program and it finally reaches this line containing the for loop, it performs the initialization step one time. So it declares that int I equals 1. So that's a variable declaration. It makes a variable named I, and it stores the value 1 into that variable. Now, once Java's done with that initialization step, the next thing it does is it performs what we call the test. So it asks whether the test is a true statement or not. So that's what we called step 2. Now in our code here, the test is I less than or equal to 3. So Java is going to look at the value of I and see whether it's less than or equal to 3. And if that's a true statement, if I really is less than or equal to 3, then the for loop forks over to the right on our diagram here. It enters the yes branch of this diagram. And that means it will execute the statements inside of these curly braces. We sometimes call those the controlled statements because they are controlled by the loop. So since yes, 1 is less than or equal to 3, 1 is less than or equal to 3, that means that we'll enter the loop and we'll execute the controlled statements. That's step 4. So you'll notice we're jumping a little bit out of order. We go 1, 2, 4. So we execute the controlled statements. That means that println statement inside the braces there, that produces this line of output, 1 squared is 1. That's because the value of I still has 1 on our drawing there. And now, after we've finished performing those controlled statements, we do the update step. That's what we called step 3 here. And the update step of our loop says I++. And so I++, of course, that means to increase the value of I by 1. So I goes from 1 to 2 here. Now, after we're done performing that update, the loop goes back and performs its test again. And so we talked about the test being I less than or equal to 3. So now what we're asking is 2 less than or equal to 3? Because I's value has gone up to 2. And so, of course, 2 is less than or equal to 3. That means that once again, we're going to enter the yes branch of the loop here. And when we're in the yes branch of the loop, that means that we'll execute the controlled statements again, the println statement. So that prints 2 squared is 4. We perform the update again. That does I++. That makes I equal to 3. We wrap around to this test again. We're asking is 3 less than or equal to 3? And of course 3 is less than or equal to itself. So we enter the loop one last time. We execute the controlled statements with a value of I set to 3. So that prints 3 squared is 9. We perform the update one more time. That makes I equal to 4. Now we go back to the test one last time. We say, is the test true? Is 4 less than or equal to 3? And of course it's not. So that means we execute this no path here, which means that the for loop is done. The for loop exits. And once the for loop exits, we get that last line of output at the bottom that prints woo. So that's the basic idea. The loop repeats until the test becomes false. And so most of the loops that we're doing in this chapter involve loops that start with a low number and loop up to a high number. And so basically you can think of it as repeating those statements over each of the numbers between that range. So to get an idea of how this works, let's look at a Java file in our editor. Here's the code that we started with these squared values here. I've inserted a println before and after that so we can see an example of other statements outside of a loop. So the way that we would convert this to use a for loop is here we would say for each integer I between 1 and 6, we would like to do that statement right there. I'll delete these redundant copies of the statement and I'll end this brace right here. Now instead of saying 1 squared equals 1, we'll say I squared, and this will be I times I. Now this name I here that we've chosen is not special. We could have called it X or number or any identifier, any variable name would be fine. The convention is that if the variable's name doesn't really mean very much, then you're supposed to pick a single letter like I or J. Those are fairly common names that programmers use for these loop variables. So if I compile this and run it, you'll see that we get this output, hello, 1 squared equals 1, 2 squared equals 4, and so on. Now one thing that you can notice here is that the hello and the goodbye occur before and after the repetition, the for loop output. So those only print once. If you moved them here inside of the for loop, what do you suppose the program would do at that point? Well, based on the definition of the for loop, every line of code that's between these braces here is considered a controlled statement. So it will repeat those lines over each of the values in the range that you've specified here. And so actually what this will do is for each value I between 1 and 6, it will print all of these 3 lines. And so if we compile that and run that, you'll see that it prints, hello, 1 squared equals 1, goodbye. Hello, 2 squared equals 4, goodbye. Hello, 3 squared equals 9, goodbye, and so on. It'll print the hello and the goodbye 6 times, just like it prints the squaring lines 6 times. So it's important to understand which lines are supposed to go inside of a loop and which lines are supposed to go outside. If I only wanted one hello, I should put it outside of the loop, ahead of the loop. And if I only want one goodbye at the end, I should put that outside the loop at the end. We can walk through the execution of the loop in the debugger if you want to see the details of how it really runs this code. One thing that I'll do just to make it look a little bit cleaner in this particular debugger, the debugger stops on given lines, and so I'd like to notice which of these pieces of the loop header are being examined each given time. So for me to see that, actually this editor would ask me to split the for loop onto different lines. It's okay to do that. It has the same semantics, the same meaning if I split it on the lines like that. But the advantage will be that when the debugger is moving around, I can see which of these statements here it's executing. So I'll compile this real quickly here. And I'm going to run this as a debug mode with a breakpoint set at the start of the program so that I can step through each line of execution. So here I am on the first line of the program, and I'll step, and that will cause the hello to print. Now I'm at the for loop, so it will first execute the int I equals 1. You'll see the variable I initialized to 1 in my debugger here. Now the next thing that it does is it checks, is that less than or equal to 6? And yes, it is. So the loop enters and it prints the controlled output here. 1 squared equals 1. Once it's done doing that, it performs the update. I++, I becomes 2 here. Now it checks again, is I less than or equal to 6? Yes. I'll run the controlled statements. 2 squared equals 4. I++. Is 3 less than or equal to 6? Yes. Controlled statement. Update. Is 4 less than or equal to 6? And so on. And eventually, now here's the last repetition, 6 is still less than or equal to 6, so I'll print that statement. I'll perform the update. Now I is 7, and so when Java asks, is 7 less than or equal to 6, the answer is no, so the for loop will exit now, and now it will produce the goodbye as the last line of output. It's possible to have a for loop that doesn't repeat any times at all. If you have a loop that starts at 10 here and you ask to repeat as long as I is less than or equal to 6, well 10 already is not less than or equal to 6, and so if we compile and run that program, you'll see that it just prints hello and goodbye because there's sort of no numbers in that range, if you want to think of it that way. But we don't have to write a for loop that just goes from 1 up to some given maximum. We have a little bit of flexibility in how these loops work. So here are a couple of variations of for loops that might interest you. One is that the initial value and the ending value for your range of numbers can be anything you want pretty much. They could be negative numbers, they can be very large numbers, they can be expressions. So like this one right here assumes that we have a variable named highest temp, and we're setting this maximum to be highest temp over 2. That's 7 over 2 in integer division, that makes 3. And so this for loop repeats -3 through 3 inclusive and prints different temperatures, I guess, over that range of values. Another variation that you can do to the for loop is that you can use a for loop that counts downward. So maybe we want to count down t-10 down to 1 and then blast off. So if you want to do that, you say that you start at 10 and you end at 1, but there's a couple things that are important to change beyond just those numbers. The other things that you have to change are you have to tell the loop to count down by decreasing I each time through the loop. So every time the controlled statement here executes, after that, I want I's value to decrease by 1, so I say I minus minus. The other thing I need to change is I need to change this test. I need to say, I would like to keep repeating as long as I's value is greater than or equal to 1. If you say less than, then the loop will never begin because 10 is already not less than or equal to 1, so the loop will never get started. But if you say here, I want to keep looping as long as I is greater than or equal to 1, that will count down until you hit 1 and then go past that and then stop. So for example, if I go back to my editor here and I change this to be 10 and this to be 1, then I'll make those other two changes. I'll say I want to count down and I want to continue as long as I is greater than or equal to 1. And now when I compile and run that, I'll see that I have hello 10, 9, 8, 7, 6 all the way down to 1 squared is 1, and then I have goodbye.